Hi everyone, it's Mrs. Watford and I am going to walk through FRQ number 1 for the Chapter 6 possible FRQs that could show up on your test. So this first question comes from an actual AP exam a couple years ago where you have a Ferris wheel with a passenger compartment and it contains a bench on which the book of mass M, MB, is placed. So we know the mass of the block. The compartment moves with a constant angular speed. We have not talked about constant angular speed, but all that means is it is moving at a constant speed in a circular direction. Radius is R. The bench remains horizontal throughout the compartment's motion. And then we have a magnified view of the compartment. So then we have a graph that shows the horizontal component of the book's position as a function of time, where the positive x direction is to the right. So if we look at this diagram right here, would be x equals the positive amplitude, and right here would be where x equals the negative amplitude. And instead of amplitude, I'm actually going to rewrite this to say this is position negative r and positive r, because we know that the amplitude, the distance that it travels, is the radius of the circle. So we can look at the graph and see that this goes from positive 30 to negative 30. So that tells me that the radius is going to be 30 meters. Part A says determine the period of revolution of the book. So period is the time for one revolution. Well, one revolution is going to go from the top of one crest to the top of another crest. Always make sure that you're measuring from top to top or bottom to bottom, not center to center, because one center to the next center is only half of the revolution. So it needs to go all the way around and return to the same position in order to be one complete revolution. Well, if I look at those numbers, T, which is the abbreviation for period of revolution, is going to be 120 seconds. And I just get this from reading the graph. Part AII says calculate the tangential speed, not the angular speed of the book. When we study rotation, you'll be getting into angular speed, and we'll be calculating all of that in radians per second. But for now, all we care about is the tangential speed. So velocity is going to be the change in position over time. Well, what is the change of position for a Ferris wheel that is traveling in a circular path? It's going to be 2 pi times the radius, because that's going to be one revolution, divided by t, which is the period of revolution, or the time that it takes. So if I plug these numbers in, I'm going to get 2 pi times 30 meters divided by 120 seconds, which gives me 1.57 meters per second. So that's my period. This is my tangential velocity, and the radius of my circle, which it didn't ask for, but we figured that out from the graph. That's where we got that information. Moving on to part B. On the dot below, which represents the book, draw and label the forces, not components, that act on the book at the lowest point of its circular path. Blah, 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 blah about the arrows. Be careful about your arrows. Make sure that you draw them correctly. Now, if I go back up to the first page here and I look at the forces on the book is not attached to the top of anything. So the book is sitting on the bench. So the book has weight and the book has a normal force. And if we're looking at this position right here, the book has weight and the book has normal force. And since this is traveling in a circle at the bottom of the path, F net is going to be towards the center of the circle so that it will stay in circular motion. So that means that normal force is going to be greater than weight at that point. So now to go back and answer part B, draw and label the forces. So we have normal force and weight. And as long as you use something that is appropriate, you can label it really anything that you want. You could say the force of the book of the earth on a book. You could say the force of gravity. You could say the force of the compartment on the book, anything like that. But it is just the normal force and weight here. At the lowest point of the circular path for part II, which is what we just looked at, the book is moving only in the horizontal direction. In what direction, if any, is the net vertical force on the book? So the net vertical force, which we just discussed, is going to be up. So without deriving any equations, briefly explain your reasoning in terms of the book's motion. So yes, the velocity is going to be this way, but the acceleration is going to be that way because this is traveling in circular motion. All right, so our answer here is going to be something along the lines of, because the book is moving in a circular path, that means that the net force is the centripetal force, which is going to point towards the center of the circular path. Part C, derive an algebraic equation for the vertical force, that would be the normal force, that the bench exerts on the book at the lowest point of the circular path in terms of the book's mass, tangential speed, radius r of the path, and physical constant. So G is considered a physical constant. Do not substitute any numerical values or variables for physical constants. So for part C, we always start with an equation from our formula sheet. So first of all, I'm going to say that the normal force is the vertical force of the bench on the book. So the sum of the forces on the book is going to add up to equal MA. And this is going to equal, because the sum of the forces is the centripetal force, that's going to be mv squared over r. And because AP gives us some little subscripts here, we're going to add that. So mass of the book, velocity of the book over r. What are those forces that are adding up to be the centripetal force or net force here? That's going to be normal force minus weight. So if I just rearrange this to solve for the normal force is going to be equal to mb vb squared over r plus mbg, and I should have put a little b here next to my mg. If you want to, you can factor out the mass of the book, So it becomes mb times parentheses vb squared over r plus g. But that is a preference. Either one of these answers is going to be an acceptable answer for this derivation, and they do not want you to substitute any numbers for this. Part D says at the lowest point of the circular path, is the force that the bench exerts on the book greater than, less than, or equal to the weight of the book? And the answer here is going to be greater than. And so what is our reasoning? So because the net force is a centripetal force, F net must point to the center of the circular path. F net is upward at the lowest point of that circular path. So that means that Fn, the normal force, must be greater than mg, which is consistent with my derivation. And I said that mb/vb squared over r plus mg is going to be greater than mg by itself. And so that is the solution for question 1 of the Chapter 6 possible FRQs for